Hey everyone, welcome back to the channel. Today's debate is between FTFE and Flat Out Hero. Not like most flat earthers, Flat Out Hero comes with no evidence, complete misunderstanding of physics, and tries to strawman physics at every turn. And he's especially bad at math. Like a lot of flat earthers don't like math. But as far as his intelligence goes, it's pretty questionable. As a matter of fact, FTFE addresses it during the debate. I'll let you take a look at exactly what I mean. Here we go.
I am Flat Out Hero. I'm all about telling everybody to look at what is going on around them, to test the things that you hear from NASA, and to definitely test and see if you can find curvature, see if you live on a ball. That's all I'm here to do.
Right, cool. Test to see if we can find curvatures. There's been lots of that. Right, so you are a flat earther. You think the Earth is flat and stationary. I don't want to strawman you. Is that correct?
No, that's correct.
Right, so what would you say is your best bit of evidence for the Earth being flat and stationary?
Well, I mean, the best bit of evidence would probably be the railgun, which the Navy has only recently began. Yeah, the railgun, because the Navy's only recently in the past, I think maybe since 2017, started to try to pull it off of their off of their funding, because they realized their mistake when they started putting out all their showing that a railgun could hit a target and there's over 200 nautical miles away, and it's a line of sight target, and it's also the railgun doesn't shoot in an arc, it goes straight. Like, so I mean, if you can go 200 miles in a straight line and like start at 15 feet and go and end 15 feet above sea level, that's kind of a little bit of a red flag. If you look at anything that they were publishing in like 2013 and stuff, when they were really bragging about it, they straight up say that they have just a piece of metal that is charged by two electric bars, and it goes straight down the railgun down the track, and it goes, what was it, like 7 times the speed of sound, Mach 7. And if you're a mathematician, right? You like math? Go ahead and do the math on that and see how far Mach 7 is going to travel in a straight line before it does an arc.
This is from Naval Railgun Tech Assessment, U.S. Navy 2004, and shows how the railgun fires in an arc. And here we have Naval Railgun FAQ and primers showing how they fire in an arc and use gravity to actually impact their target. So I am going to repeat, you are wrong. Railguns do not fire straight, they fire in an arc.
But now think about this. If you were to shoot a projectile straight 15 feet above, parallel to the water, straight 15 feet above it, and then your projectile, how far is it going to travel before it starts to arc or sink? How far will it travel?
Instantly. If you fire something perfectly, let me answer your question. You've asked the question. Let me answer it. If you fire something perfectly straightforward, it instantly starts to go towards the ground. You can fire a bullet from a gun that is the same same height of something that you're dropping, right? And both of them will actually hit the ground at the same time. Your claim, let me clarify, your claim was that railguns show that is the best proof that you have that the Earth is flat and non-rotating because they fire in a straight line. You are wrong. They use an arc that they fire in and require gravity to kinetically impact their targets.
They line of sight target.
It's not line of sight target. It is not a line of sight target. That is completely false. You will never ever find anything in
the other part of it.
You will never. No. Let me be clear. You will
200 miles across the ocean.
All right, carry on. Sorry. Right.
That was all I had to say. You can see 200 miles across the ocean.
Yeah, but railguns are not line of sight. They use
are
GPS. I've just shown you from military manuals that it is not.
But Wikipedia, railgun, just like it.
Yeah, I'm not going to use Wikipedia. I'm going to use the military manuals.
Okay. Well, you're using a military manual that goes against what other things that they have published. So I don't know.
All right, present me evidence that they have ever published something that says it is a straight line of sight target.
How does a straight metal projectile go over the curvature of the Earth? How does that happen? Think about
because it fires in an arc.
No, you saw the diagram. Your proof right there.
Do you want me to bring it back
up?
up?
Curvature,
do you want me to bring it
up
back
and
up?
over to aim it up. They have to aim it up above. They don't aim it up when they're firing for the line of sight target. They aim it straight at it.
Railguns fire in an arc to impact their target, as shown here by the ONR. These are the people that actually make it. The electromagnetic railgun shows how the direct fire from the horizon, the 6 seconds, ballistic trajectory, then GPS guidance in an arc. And then it shows here with the launch dynamics, showing you when it fires and goes up in an arc.
Search this on YouTube, railgun projectile in flight, and see if it arcs. Go for it.
Railgun projectile in flight. You want me to go and search for your evidence for you?
I want you. Yes, you showed one of yours, and that's all I'm asking. Yeah.
No, but I have just shown you evidence from the military that you are wrong. Are you going to ignore the evidence that I have presented and still claim that you're right?
I'm trying to show you my evidence, and then we can decide. How about that?
But you haven't got any evidence. You've just made a claim and didn't bring evidence to back up your claim. This was specifically set up so that they could record it in a small scale, short range,
because it demonstrates the long range. It demonstrates the scaled up long range. That's why they did that.
But I have just shown you military manuals. I have just shown you military manuals.
If it was going to arc on the short range, then it could show in the long range. But if they're
firing over such a short,
they wouldn't do a test run where it doesn't arc if it did arc. All right, if you're going Mach 7 parallel to the ocean or parallel to any body of water that's flat, you're going to have what is that? That's 6,000 times 7. This was like 30. It's about, I don't know, 28,000 miles per hour. If you put that down to what, divided by 60, so you'd hit curvature, or you'd start going up above the.
Why would you hit the curvature?
Well, you'd go above the curvature at 1 mile, you'd be above 8 inches. 7 miles, you'd be about like 36 feet. They don't. Their test demonstration does not show that it would do that.
And they can hit something
200 nautical miles away without having any guidance to it.
They do have guidance. I've shown you they have GPS guidance from at least 2004.
No, that didn't say it had GPS guidance.
Do you want me to go back to it and show you again, because you obviously weren't paying attention? You claimed that the sun is a burning ball of gas in a vacuum that needs oxygen. Do you want to explain that?
Any type of explosion or fire that we can recreate ourselves, that we can actually test and see. Fusion, we can't test that. We can't do that. That's not, me and you cannot do that. So anything that we can test, that fire is going to need oxygen, right?
The sun is not gas, and it is not on fire.
It's not hydrogen? It's not hydrogen.
It's mostly hydrogen, but it's not on fire.
That's a what?
It's not mostly hydrogen. It's about 1.2% oxygen, actually, interestingly. But it is not on... Let me be clear here. Let me be clear. It is not gas, and it is not on fire.
What is hydrogen?
Hydrogen is an atom. An element.
Okay. Is hydrogen a gas?
Hydrogen 1, in its base form, is a gas. Not all hydrogen is a gas, no. You can have metallic hydrogen, you can have liquid hydrogen, but the sun is mostly plasma.
Wait, but I thought you said it was mostly hydrogen.
Yes, mostly plasma, yeah. Do you know what plasma is?
No, I'm not. I know that it's a super hot element that you can make in like microwave grapes. Is about as much as I know about plasma.
Yeah, that's quite fun actually. But it's an atom that's been ionized. Its electrons ripped away, removed, right? So it's got an electrical charge.
So now
it is hydrogen, right? But it is a state of matter called plasma that is hydrogen. There is no gas on the sun, and the sun is not on fire.
So when did they first start pulling away the electrons and protons from atoms? Was that before or after they could actually see one?
Excuse me, the fuck did you just say?
That's always been going on as long as there's been plasma in the universe.
Okay, sure. So they've been pulling neutrons and electrons.
What question was that? Sorry, ask that question again.
Yeah. Okay. How did they pull neutrons and electrons or protons or whatever out of it.
Who said anyone pulled like protons or neutrons away? I said specifically electrons.
Okay, electrons. How did they do that when they couldn't even see it?
So we know what plasma is, and the sun is plasma. It is not a burning ball of gas, so your entire nonsense is null and void because you have strawmanned what the sun is.
The sun and the moon are the same shape, the same size, and they're both come above us, the same pattern.
Size.
Huh?
The same angular size, but not the same size.
Okay, well, whatever, they look the same to us, to our eyes. What we can see, what you and I can verify, they're the same size.
The ISS, when looking at the Earth, can only see about between 2 and 4% of the Earth's surface. All right, it's not very much. So they're actually relatively close and can make out quite a lot of details. The Moon, 1/6 the Earth's size, a 250,000 miles away. You can't make out any detail on the Moon. You can just see shapes and some shadows and stuff. You cannot make out any detail on the Moon with your bare eyes. You need magnification to actually be able to see the craters. So your entire point is null and void because you have no evidence for what you claim. It's just claims.
You agreed we could see the face, so you can see detail.
You can see the entire face of the Moon, yes, not the individual details of craters or mountains.
Face, the two eyes and the mouth, you can see that.
Oh no, I don't mean that you can see. I mean you can see the entire face of the Moon.
Everybody in history, including you tonight, when you go look at it, can see the face of the Moon.
Yeah,
everybody. The face of the Moon
that's not detail. That's just random shapes. You cannot make. Let me be clear. Let me be clear. Don't let me finish. Don't let me finish. You cannot make out any individual craters or mountains on the Moon with your naked eyes. You can see vague shapes from geological features that are very far away, but you cannot categorically make out any detail on the Moon without some kind of magnification. Can you present me any maths or any experiments that could back up your claim that we see too much detail on the Moon with our naked eyes?
Sure, fucking YouTube.
No, YouTube isn't anything scientific.
YouTube video of the Moon. That's all you got to YouTube, and they're going to show it to you. Unzoomed, no zoom video of the Moon.
Yeah, no zoom. You can't make out detail. Zoom in, you can make out detail. Zoom in, you can make out detail. Zoom out, you cannot make out detail.
Well, go ahead. Let's see it. YouTube it. Let's see it.
Zoom in, you can see detail. Zoom out with your naked... And anyway, we're not talking about a camera. We're talking about with the naked eye, which was your claim.
So are you just going to claim victory when
yeah, like, because you're absolutely wrong. You're making stuff up with nothing to back it up. You cannot categorically make out details of mountain ranges and craters on the Moon with your naked eyes. It is not possible.
Okay, I already made a video about it. How about that?
ISS. Yeah, do you want to do the maths for that?
No, I want you to show me, like I asked in the video, of any other time that you can see something smaller from closer or from farther away than you can see something that's much larger.
Yeah, that doesn't happen, that bunch of you just made. We're going to do the maths. We're going to do the maths, right? We're going to do the maths. We're going to do.
It doesn't happen.
We're going to do the maths, and you're going to be quiet and learn something. So, to find out the angular diameter of something, for instance, the ISS, you use this formula. Alpha equals 2 times the arctan of G over 2r. Well, alpha is the angular diameter of the object, G is the actual size of the object, and r is the distance to the object. All right? So we're going to plug in the numbers here. So alpha equals 2 times arctan, and G is the actual size of the ISS, which is 72 meters. We're going to do this in kilometers. So 0.072, and then we'll divide that by G 2r. And the distance I'm talking.
That's only how long it is. That's not a dimension. What's the rest of it?
Angular diameter.
No, 72 meters by what?
We're doing it 72 meters across.
Okay, 72 meters by what? By what?
Well, it doesn't matter because we're getting the angular diameter.
Right? That's not showing the size of anything. That's showing the length of something.
So when we plug in these numbers, what we get is an angular size of 0.01 degrees, right? That is the angular size of the ISS at the height it is with the size it is. Now, let me show you a citation.
So your calculation said that you should see something 72 meters across?
No, I've not said that. All I've said is the angular size is 0.01 degrees. At 0.01 degrees of angular resolution, you are not going to be able to make out any details. It is going to be a tiny dot, but your eyes will be able to see it because it matches the angular resolution size of your eyes. Now, even if it was below the angular resolution size of the eyes, you can still make out the ISS most of the time because it ends up being a point source of light because sun reflecting off of the solar panels. And it matches the limitations of the human eyes. So seeing the ISS is no problem. I'm done. You can respond. Oh, he went away. You seem to have disappeared and then come back. That was all an explanation for nothing, I guess.
Sorry, I got a phone call and it kind of messed up the volume. I couldn't hear you.
I am going to present evidence that the Earth rotates in 3 axes, which, if it does, it has to be a sphere.
How did you come up with that?
We measured it. Pretty simple, actually. Because if you can measure something, then it exists, right?
What was the tool used to measure it?
A pendulum.
A pendulum?
Yeah.
Very
simple. So, I'm surprised you've never seen this before.
Did they have to push it at the beginning?
Irrelevant.
If they have to push it at the beginning, if they have to start it to start it to get it to start rotating,
irrelevant to the entire point. So please don't strawman what I'm going to say before I've even said it. Okay.
Well, I'm just saying, if it's pushed or if it doesn't start on its own, then there's
it's not supposed to start
rotation.
on its own. That's not what we expect.
Well, yeah, it is what you expect. If it's going to,
it's not what we expect. It's not what would happen, and it's not what we expect. That's a straw man of my position.
Rotation, because it's going to alter its swing. Then it's obviously going to have enough movement to make it swing.
No, not at all. It maintains its motion relative to the Earth when it's still and hasn't had a swing put onto it. There's no reason in physics that a pendulum should start swinging on its own when it's just sitting on an Earth. We are not talking about the fact that it had to be started. That is irrelevant. Physics doesn't say that it should start on its own. What's important is the drift induced when it is swinging backwards and forwards. That has to be explained if the Earth is flat and stationary, that it is predictable and that you can use that to calculate your location on the Earth. So, are you able to give me an explanation for how this happens if the Earth is flat and stationary?
Well, when you push it, is there a machine pushing it or is that a human pushing it?
That wasn't the question.
No, that was. I'm going somewhere with it. So now answer me. Is it a human pushing it?
In the experiment I just showed, he lit a lighter on a bit of string to release it so it could move, so it could swing backwards and forwards. But again, the question to you was, how does the flat Earth explain the drift induced on the swinging pendulum that matches your latitude on Earth and your hemisphere? How does the flat Earth explain that if we are not rotating? Because that matches the predictions of rotating.
Wait, so you're saying that if it goes around and it makes a full circle after, if it were to be swinging forever, if it could swing forever, you mean like if it was having any forces imparted upon it, like it were to swing forever instead of just swinging for a little bit? Because in order for something to affect it, it would have to be starting it. If it can affect it,
no, that's completely wrong.
No, if it affects it, you would see it move.
No, it's completely wrong. And you're avoiding the question. You're avoiding the question. The question is the question is, how does the flat, non-rotating Earth explain the drift induced onto a swinging pendulum?
I just said it doesn't fucking prove anything unless it starts running by itself.
Right? We verified our hypothesis of a rotating Earth by seeing the drift induced onto a swinging pendulum. And that is what we need to concentrate on. That drift induced. Why, if the Earth is flat and non-rotating, was there a drift induced on that swinging pendulum?
No idea. No idea what's going on with it. It doesn't have anything to do with the Earth being rotating.
It matches the predictions of a rotating Earth.
match because the prediction would be that if it's a force that can affect it, it would start it in.
No, that's you not understanding physics.
Well, show me where I'm wrong.
We do not expect a pendulum to start swinging on its own because conservation of momentum and gravity are both things.
Well, are they?
If something that we expect to happen happens, what can we infer from that?
Well, I don't know how you could expect it to happen when...
Because that's what physics says should happen.
It's not what's happening. If you expect something to affect something, then it's going to affect it.
It does affect it, and it affects these... The Coriolis force does not make things start, and you are strawmanning the Coriolis force by saying we expect it to make things... You are strawmanning the Coriolis force by saying we expect it to start movement in a linear fashion. Coriolis force does not do that. Coriolis force induces a force on something that is already moving. So what we are seeing in that pendulum is evidence that Coriolis force exists because the Earth rotates. If you cannot explain it with a flat non-rotating Earth, that means it is evidence that the Earth is not flat and non-rotating, and it is in fact evidence that the Earth is a rotating globe, because it matches the prediction of such. Just because you don't understand it doesn't mean it's invalid.
No, well, now look, here's what I do understand. You can't provide any other example of a force affecting something without it starting.
Centrifugal force, gravity.
Okay, that's not a force.
There is a force created by gravity, 100%, we can measure it.
If you want to call it a force, then great. So now if you're going to say it's a force, does that mean it's a force like magnetism? Is that the kind
It's an apparent force in a reference frame, otherwise known as an inertial force, or a emergent force, or a fictitious force.
What does this affect specifically? Mass?
Everything with mass, yes. And
everything with mass.
Everything with or without mass, actually. Just everything in the universe.
Like helium?
Yes.
Okay, so then, and how is helium able to overcome gravity?
Do you know the equation for buoyancy?
It doesn't matter. I'm saying...
No, it does matter. Do you know the equation for buoyancy, yes or no?
Nope, don't know any equations. You can
of course you don't.
See that.
So the equation for buoyancy is FB, which is the force of buoyancy, equals rho, which is the density of the medium, times G, which is the acceleration due to gravity, times V, which is the volume displaced. So buoyancy is a result of gravity. So when a helium balloon is going up, that's because gravity is pulling the more dense, heavier things around it down with more force because there's more mass, which creates a force in the opposite direction to gravity, forcing the thing less mass, less density, the opposite direction. Buoyancy, helium balloons and everything like that are a prediction of gravity.
Is gravity alive?
Of course not. That's dumb.
Okay, so then, well, I mean, it's picking and choosing how much force to apply on. How does it pick and choose how much force to apply?
Different mass means different force. Let me. You've asked me a question. Let me fucking answer. All right?
Okay. Okay.
Fuck's sake. Right. So, if you get a paper clip or a big metal ball, right, and put them the other side of your hand where the magnet is, the big metal ball will be creating more of a force towards the magnet than the little paper clip is.
No, it's more weight.
So you're wrong.
More weight, not more force. The force.
Weight is a force. Weight is a force. Weight is a force.
It's not the magnetism force. It's the force of weight.
Yeah, due to the extra force created by the magnetism, which is proportional to the amount of material. The same way that with gravity, more mass means more force, because the most basic physics equation that you have is F equals ma. Force equals mass times acceleration. Everything will accelerate at the same rate. That means that things with more mass have more force acting upon them.
Okay.
Seriously, look, your ignorance of physics is not an argument against it. If you had enough time and distance, those things would end up traveling the same acceleration. They would go the same velocity eventually. However, because it needs more... Are you going to let me finish what I'm saying? Why is it you have the inability to shut up when I'm trying to respond to you?
Because you're not responding to me.
I'm literally trying to respond to you, but you keep opening your fucking mouth. Why is it you can't shut up now, but trying to talk to you over Hangout is like pulling fucking teeth?
Probably because I got a job, I got a life.
Yeah, so you can't look at your phone?
No, not.
Of course not. Of course not. Frictions can create a force, right? And surface area of, so for instance, if a skydiver is falling down, they reach terminal velocity because the surface area creates enough force in the opposite direction to the acceleration of gravity, right? Because it's creating friction against the air. Let me talk, right? Don't interrupt until I've finished. I'll let you know when you can talk, okay? Until the acceleration of gravity is balanced out by the resistance caused by the air acting upon the surface area of the skydiver. That's simple drag physics, okay? So that's what we expect to happen. If you're in a complete vacuum, you do not have terminal velocity.
Oh, can you show that?
Yeah, things don't, like, reach terminal velocity in a vacuum.
I've never seen a vacuum not talk. Can you show that? I tried to look for it.
Yeah, well, there's no reason to have terminal velocity because there's no force acting in the other way. What force in a vacuum? What force in a vacuum would cause something to stop the acceleration?
There's nothing stopping the acceleration in
apart from the air resistance, of course, acting on the surface area of the skydiver. Are you telling me that when you move your hand through the air, you can't feel the air on your hand?
There's no against my hand. There's my hand pushing against the air. There's no force against it. That's my force.
You're feeling resistance, right? And if you stick your hand out of a car window, does your hand not get pushed back by the air?
Because that's wind. Wind is not blowing up.
Excuse me, are you saying that if you're traveling 60 miles an hour in somewhere with no wind, are you saying that if you travel 60 miles an hour in somewhere with no wind, your hand won't get blown back as you stick it out the window?
Can I talk?
I asked a specific question. Answer the question.
Mute yourself. I'm muting myself. You mute yourself.
Answer the question that I've just asked.
I'm going to mute yourself.
No. Just answer the question.
Are you going to shut the fuck up then?
Answer the question specifically.
Are you going to shut the fuck up then?
Answer the question.
Look, here's the answer, bro. If you're going to say that the wind is a force because you can put your hand out of a window and feel that, fine. Wind is a force. I don't disagree at all there. But
didn't say wind was a force. You're strawmanning me.
Fuck up, dude. No wind blowing up against the skydiver. There's only the skydiver.
You are strawmanning me. I never said wind is a force. Fuck me. Right. I didn't realize that you had got stupider. And to understand it, you would at least have to tell me Newton's law of gravitational attraction. Can you do that?
Wait, do what?
Can you tell me Newton's law of universal gravitational attraction?
Mass attracts mass.
No. What's the actual law? It's mathematical.
No, I can't tell you the mathematical law.
So why are you trying to debunk gravity if you don't even know what it is?
I don't have to understand that to understand.
Yes, you absolutely do. If you do not even understand that Fg equals gm1 m2 over r squared, then you are not qualified to be discussing gravity. Now please explain how measurements from a fiber optic gyroscope match that from a swinging pendulum.
I have no explanation. It doesn't.
I do. I have an explanation. It's because the Earth's rotating, and that's what we expect to happen.
Well, you expect that. We expect to. If we're seeing the force applied on objects, we expect to feel the force.
What you just said was, "I do not understand physics."
It doesn't matter about understanding.
So let me ask you, where did you study physics?
It affects the object.
So where exactly did you study physics? Just out of interest, where did you get your qualifications in physics to be able to debunk all of physics? Just out of interest.
You don't need any. You don't need any.
Right. So you think you are smarter than every physicist in the world?
Nope. Not at all.
You are currently disagreeing with every physicist in the world.
Okay.
So you are saying that you know better than every physicist in the world.
I'm saying that they were taught to believe things that are fucking.
No, physicists don't do that. Physicists experiment and verify.
If you think so, fine.
No, I don't think so. Physics says so.
Good.
Let me check. Hold on. Hi, physics. Hey, how you doing? So if you've got a swinging pendulum, right? In fact, don't worry about swinging. If you've just got a pendulum on its own on a rotating Earth, do you expect the pendulum to just start swinging on its? Oh fucking hell! No, I'm sorry. No, yeah, I know it's a stupid question. My bad. Sorry. I asked physics and it said no. Sorry about that. Physics in general disagrees with you.
I don't mock you on my channel. I don't fucking care about you, honestly. Like I don't have any reason to mock you. And if you're gonna try to mock me, you can do that.
It's very easy to mock you. I mean, in fact, you kind of do it yourself with the things that you say, like the sun is a burning ball of gas. Oh, he's ran away. Rage quit.